So today we're going to do problem 2483, minimum penalty. Why did I stop? It's for a shop. Yeah, so let's go ahead and get right into this problem. Full disclosure, I haven't had an opportunity to attempt this problem yet, so this is going to be my first time having exposure. Full disclosure, this is my first time having exposure. Ladies and gentlemen in attendance, can I have your attention for a moment? I would like you to just focus. Okay, so you're given a customer visit log of a shop represented by 0 index string customers consisting only letters of N and Y. If the ith character is Y, it means that a customer comes at the ith hour, where if N indicates that no customer comes at the ith hour, okay? If a shop closes at the jth hour, 0 less than equal to j less than equal to n, the penalty is calculated as follows. For every hour when the shop is open and no customer comes, the penalty increases by 1. Yeah, that's true, man. I've worked in a small mom and pop shop. It's like you're sitting there for hours and nobody comes in. It's definitely a penalty. And for every hour when the shop is closed and the customer comes, the penalty increases by 1. Which also makes sense, right? Because how many times have you been in a situation where you went to a store, you went to a restaurant and it was closed, and you're like, what the heck? I was just about to give you a bunch of money. You just missed out on an opportunity to make money. So it's also a penalty. Return the earliest hour at which the shop must be closed to incur a minimum penalty, right? So this is kind of something that shops do, right? Like a coffee shop near me, they close at 3 p.m. Why? Because people don't really seem to get coffee after 3 p.m. So it'd be a waste of time. There'd be incurred penalty in the next few hours since nobody comes, right? But they don't want to close before 9 a.m., right? Because a lot of people get their coffee after 9 a.m. So maybe the ideal place to close their shop is around 3. Return the earliest hour at which the shop... Okay, so if a shop closes at the jth hour, it means the shop is closed at hour j. Okay, so if I close it at 3 p.m., if someone comes in the 3 p.m. hour, right? If I close it at hour 1, then if anybody comes at hour 1, I incur a penalty. Okay, so we have customers, so let's look at this example. So we have customers equals what? What does customers equal? Customers equals yes, yes, no, yes. And just so we can make this clear, right? This is hour 0, hour 1, hour 2, hour 3. So if I close the shop at the 0th hour, right? So if the shop is closed from this point forward, I lose out on... If I close the shop at hour 0, right? I lose out on this person and this person and this person, right? So I incur a penalty of 1, 2, and 3. So there's a 3 penalty. If I close the shop at hour 1, right, I close the shop at hour 1. Well, I don't incur a penalty for this person because I can now service them, but I do for this person and for this person. Right. So that's a penalty of 2. If I close the shop here, I incur just a penalty of 1, right? Because I just missed this person here at 3. And if I wait to the end of the day and I close the shop here at time 3, well, I miss out. I have an hour where nobody shows up, right? So I lose a point there, but I get penalized a point there. And since I closed the shop at this time, I also don't get to service this person. So it means I get a penalty of 2. And then if I close I guess there is an additional hour 4, right? So if I close at 4, well, I service everybody, but I also incur a penalty right here at no. So the minimum penalty is 1, right? It's either the minimum penalty is 1 and it happens at both of these indexes, right? It can happen here at time 1, right? Or it can happen here at time 4. And I think obviously, right, if you were using this scheme to try to determine when you should close your shop if you had access to, average data about when people come, when they don't show up. You should choose the earlier time, right? If I'm only missing out on one customer, right? If I'm only getting penalized one here and one here, I might as well close the shop earlier, right? Because I'm probably going to save money on additional expenses, right? That's me trying to add some real life information to this problem, right? But I mean, that does, I guess, make sense. So there's that. So how do you solve this problem? Well, there's a very easy n squared time algorithm, right? You would just look at each hour, and then you would count up to the hour and count how many people, how many hours where there was nobody there, where there's an n, and then you add up after the hour you close, how many people are what? How many people are missing, right? How many hours there people came. So you look at any index, you look at all the n's that are to the left of that index and all the y's that are to the right of that index, right? So I look at one and I look how many n's are to the left, 0, and how many y's are to the right, including this index, 2. So the penalty is 2 if I go at shop 1, right? So I could do that for everything in the system, right? I can say how many n's are to the left, so that's penalty because I was open and nobody came, and how many y's are to the right, so how many people tried to come and I was closed. So that's n squared, right? Because I don't have to do that for each index. I have to look at each index and look at every element in the array to make a decision. Look at the next index and look at every array in the system. So I think a more obvious solution here would be to use a prefix sum notion to save information that you've seen so you don't have to keep recalculating stuff for certain indices. So what you can instead do is say, well, if I was to close, is there a way that we can easily determine, well, if I was to close at time hour equals 2, I want to know how many n's are to my left, right? How many n's are to my left of hour 2? So I want information, I want to use a prefix sum notion to get n's that are less than an index. We'll call it hour, and I won't use the pencil feature. I don't know why I'm doing that. So I want to have information about the number of n's that are less than the hour, and I want to show it on the screen so you can see it. And I want to know the number of y's that are greater than or equal to the hour, right? Because that's how you get this information, right? What's the answer to this problem here? Well, there's 0 n's to the left, and there's 2 y's to the right. And what does it mean to be to the right? Well, it means it's greater than the current hour that you're looking at. And what does it mean to be to the left? It means you're less than the hour you're looking at, right? But this is greater than or equal to. So how would we then calculate this? Okay. So why don't we just use a prefix sum where when we go from left to right, we add in how many n's we've seen so far as we traverse the array, and that'll give us at each point the number of n's that are to the left, right? So let's call this n's, and we'll call this one I keep messing. Why do I keep doing that? And we'll call this one y's. Because I'm a wise man. A very, very wealthy wise man. All right, this is y's. Okay. So n's will be the number of n's that are less than an hour, and y's will be the number of y's that are greater than an hour. So we look at this problem, and we want to know the number of n's that are to the left. So I'll create this n's array here, and I'll put this in a little box and maybe clean this up a little bit so it doesn't look so insane. Okay. So we're going to hold information about what we're calculating. So when I traverse through this system, how many n's are to the left of 0? To the left of this element here? Well, 0, right? Because it's just a y. How many n's are to the left of this? Well, this thing isn't a 0. This thing isn't an n. And before me, there was no n. So this is also 0. How many things are to the left here? Well, to the left of this point, there's 0 n's. And this is currently an n, so that's 1. How many n's are to the left of this y? Okay, to the left of. If it's to the left of, you don't want to include yourself. So how many n's are to the left of this? 0. Right? So you add up this value. You look at the previous value. So to calculate n, to calculate this value, you'll look at this customer value and say, is the previous thing an n? And then you'd add in the previous thing here, because this will capture information about everything that came before it. Okay? So this is then 0. If I want to find out, okay, how many n's are to the left of y in this position? Well, there's 1 n here, and this is 0, so that would be 1. Right, so this is a running sum as I run through, if that wasn't clear. Okay, and then this final position, right, this is not an n, so it's not an additional n to the left of this element, but there is 1 n that we saw before. So if someone to the left of me said that there's n people to the left of them that have blue hair, I look at this, okay, I'm trying to find out how many people to the left of me have blonde hair. And I can only see one person to my left, right? Well, if I ask the person to my left, hey, how many people have blonde hair to the left of you? And they say 7. I'm like, okay, well, the person to my left of me has 7 people that have blonde hair to the left of them. And then I can just look at the person to my left of me, and if they don't have blonde hair, then I know, okay, he doesn't have blonde hair, and he has 7 people to the left of him that have blonde hair, and he's to the left of me, therefore I have 7 people to the left of me that have blonde hair, right? So I just ask the previous person to my left, how many people to your left are N's, right? And then if that person to my left is an N, then I add 1 to whatever they told me, but if they're not, it just stays the same. So that's kind of the intuition about how prefix sums work. Pretty sure you can understand that if you're doing this problem. So that would also just be 1. All right, and then we can play the same game, but going to the right. So playing the same game for Y's. For some reason, my pen is being weird. Okay? Well, how many Y's are to the right of nothing? Nothing, including. So for Y's, it's a little different because it's greater than or equal to, right? Not just less than. So how many Y's are greater than or equal to this current hour? Well, to my right, nobody is Y, and I'm a Y, so that's 1. Right? This value is not a Y, and to my right I have 1, so that means I have 1. This value is a Y, and to the right is 1, so that means I have 2, and that means I have 3. Right? So you notice when I do this operation, it's the same thing. I only need to compare to the previous value that I computed to find the current value. So that's, again, not to emphasize this point so much that it's like exhausting, but this is the very fundamental idea of a prefix sum. So now I have the N values and the Y values. So therefore, it's easy now to in a constant time compute each of these penalties, right? Now to find the penalty of any point, I can just sum up these values, right? The penalty at hour 0 is 3 because I just sum up these values. The penalty at hour 1 is 2. The penalty at hour 2 is 1. The penalty at hour 3 is 2. The penalty at hour 4 is 1. Right? And that means then that the answer is 2 because 2 is the minimum. 2 is the minimum case where it's the minimum hour which has the minimum penalty. Okay. So let's go ahead and get right to the code. Okay, so we'll have this N's idea and this Y's idea. And it'll be, both of them will be starting off as 0. And they'll both be the size of customer. Customer, is it customer or customer 1? So in this thing we have 4 customers and it's size 5. So actually it should be size customer plus 1. Length of customers plus 1. Okay, so those are your n's to your left and y's that are yourself including. So let's figure out what n's and y's are, right? N's and y's are. So we'll look at each customer value C in customers. Okay, we'll look at the index because we need that information too. We'll just call it hour. For hour in range, length of customers plus 1. So we'll calculate n's first. So how do we calculate n's? We said n's for an hour equals, well, if the customer to my left is an n, so the customer from the previous hour is an n, plus the number of n's that come from the previous hour. All right, so that's it for that. And then we can do the same thing for hours in range. Now this time, we'll start at length of customers, and then we'll go all the way to 0. So we're going to go in the opposite direction. So we're going to start from the right, and we're going to say, well, y's of hour equals, well, if I'm an n, right, because remember it's greater than or equal to. I just realized that I didn't set the condition here. So if this equals n, plus whatever's to my right. So again, it's this idea of a prefix sum. Okay, I'm just trying to think about how this is going to work. So the first y is always 0. It's supposed to start at index 4. So it's fine to start here because the first value to the very right is always 0. So basically, I don't need to calculate this value because it's always 0. And although it's not going to create a huge issue, the problem is that this is going forwards in the array, so it could be out of bounds. Right? This is also going to be out of bounds for the first iteration of this loop. But since it's a negative, it's going to be negative. It'll just wrap around. So Python wraps around if you go negative, right? So if you have a -1 index, it just goes from the back, versus if you go out of bounds in the positive direction, it errors. So that's why I just start here. Okay. And then what we're going to do is, what are we going to do? So let's have the hour that we're going to close at. So we'll call it closing hour. And we'll just assume that it's 0. And then we'll look at each hour. What I call it hours here. We'll look at each hour in the range. So for hour in range, length of customers plus 1. What are we going to ask ourselves? Well, okay, if the penalty of the y's of hour plus the penalty of the n's of hour is greater than, not greater than or equal to, only strictly greater than, or no, if it's less than the penalty, I'm wondering if min, I think min will do it. I don't want to, let's just see what happens. Okay, so min of ns, okay, the min of the range of the hours range of length of customers plus 1. It's fine. And then key equals, well, we have each hour, and the penalty is ys of the hour plus ns of the hour, right? The penalty of people that came after and you closed at this hour, and the people that came that didn't come before while you were open. Blah, 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 blah. So I might regret doing it like this. But I'm pretty sure that min will always return the first value that's min. All right, so there you go. So this is end runtime. Seems very slow for some reason. I think it's because of the way that I'm doing it. But that it's slow because of the way that I'm doing it, obviously. Yeah, but see, there's a huge variance. So what's the runtime and what's the space for this solution? Well, the time complexity, so let's call n the length of customers. So in terms of time, well, we create an array that's the size of n plus 1, size of n plus 1, so 2n plus 2 operations. We have to go through customers plus 1 once, so that's 3n plus 3. This is 4n plus 4 minus 1, 4n plus 3, right? So we're doing these operations. I'm just basically saying you do n operations in this loop, n operations in this loop. Within each loop, you're just doing something constant. So you have an n plus an n plus an n, and then plus another n to traverse through the whole system. But so that's 4n, 4 or 5n, something like that. But that 5 is just a constant, right? It doesn't matter how large n is. It's always just going to be 5n. So therefore, this is O of n. And then what about space? Well, for space, right, we have to look at each customer and put it into a prefix. Not each customer. We have to look at each hour, right? And hours correspond to customers. And we have to create this n's array and y's prefix sum array, right? These two prefix sum arrays to allow you to constantly check values. So that means that you also need, you need n space for each of these two arrays, right? N plus 1 space, actually. Therefore, you have to use, big O of O(n), big O of O(n), big O of O(n), big O of n. And yeah, so that's pretty much it. So I'm kind of wondering if there's some little trick I'm not seeing here. Maybe I'm almost certain we're going to have to use O of n space and O of n runtime, but maybe there's a little bit of pruning that could be done to remove one of these arrays or something. I'm not sure. Probably going to get bad catch speed the way you're doing this too. Maybe, I don't know. But no, I don't think so. Who cares? All right, guys. Have a good day.